Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome and thank you for joining us for today's Oxygen Talk brought to you by the Oxygen Alliance. My name is Elizabeth Tabayaba, a biomedical engineer working under the Open O2 Project Initiative, and I'm excited to be your host today. So Oxygen Talk is a virtual meeting where we discuss various topics related to medical oxygen. I'm hosting this call from Lilongwe, Malawi, and I would like to know where you're joining us from by typing in your name and location in the chat. If you want to be added in our emailing list and get notification of upcoming events of the Oxygen Alliance, please type your email in the chat. So today, we are privileged to have special guests on our talk from Partners in Health. We have Francis Sambani, a biomedical engineer from Partners in Health in Lesotho, and Grace Guanali, another biomedical engineer from Partners in Health here in Malawi. So alongside them, we have a biomedical engineer for Oxygen Alliance, Lloyd Kayembe, and a biomedical engineer, Irene Makina, working under the Open O2 initiative. So they will discuss knowledge on PSA plants, sharing the technology behind PSA, the maintenance and safety consideration, and they will also share with us the experience in maintenance of and operation of PSA plants. So I'm really excited that you are there. And I encourage you to take notes as we look forward to hearing your questions and comments at the end of the presentation. So without taking much of the time, let me hand it over to Irene Makina to start us off. Over to you, Irene.
Thank you so much, Elizabeth. Welcome. My name is Irene Makina, and our today's topic is on pressure swing adsorption, oxygen plants, engineer's insight. We will take you through the following. The introduction and technologies of PSA plants components and functions. Then we'll have our biomedical engineers from Partners in Health who will shed more light on operation and safety and maintenance on PSA plants, and also they will share with us their experience and on the challenges they face working in PSA plants. Medical oxygen is an essential medicine used to treat respiratory illnesses such as COVID-19, pneumonia, and asthma. Oxygen is also used during surgery procedures. We have a number of technologies that are applicable in oxygen production plants. First, let's look at liquid medical oxygen. In liquid medical oxygen, this uses the technology of fractional distillation. So the steps that are involved includes the filtration of air to remove impurities, compression, liquefaction, and diluvification by cooling. So we have carbon dioxide, which liquefies at minus 80 degrees Celsius, is removed, followed by further cooling to minus 200 degrees Celsius. This cooled liquefied carbon dioxide free air is passed through fractioning column warmer at minus 183 degrees Celsius. Since nitrogen boils at minus 195 degrees, it exits the column, leaving behind the liquid oxygen, which is further purified to remove argon. Thereby, we are able to achieve 99% purity, which is stored in cryogenic tanks. We also have vacuum swing adsorption plants. In VSA technology, we have a lobe compressor that pushes air into the oxygen generator and pulls the oxygen out of the oxygen generator. The generator in this case, it consists of one absorber vessel. In VSA technology, the produced oxygen purity is up to 93% with a tolerance of plus or minus 3. Furthermore, we have a commonly known PSA plant. This similarly is similar to a VSA technology, which involves adsorption. Only that in this case, we are having high pressures of 4.5 to 7 bars. And the oxygen generator consists of two absorber vessels. Similarly, the production oxygen purity is at 93% with a tolerance of plus or minus 3. So as of today, we are focusing much on PSA plants. Let's look at the technologies associated with PSA plant oxygen production. So in PSA generator, we have adsorber material, which is the heart of the PSA process. A specified zeolite is chosen for the medical oxygen production that has a high affinity for nitrogen, allowing it to selectively adsorb nitrogen molecules from the air. The PSA cycle involves two main phases, the adsorption and also the desorption. During the adsorption phase, compressed air is introduced into the vessel containing absorbed material, where nitrogen molecules are adsorbed while concentrated oxygen passes through. When the adsorbent becomes saturated with nitrogen, the vessel is depressurized, letting the adsorbed nitrogen out this is called the desorption phase. So the adsorption and the desorption is achieved through this pressure swing between the high and low pressures. So further, there is the production purification that is done using several technologies to achieve a maximum percentage purity of oxygen. So from now, I will invite my friend, my colleague, Lloyd, to take us through the parts and functions of PSA technology. Thank you.
Thank you so much, Irene Makina. My name is Lloyd Kayembe. I'm a biomedical engineer for Science, and I'm going to take you through the main components of a PSA plant. So in a typical PSA plant will contain each of these, a compressor, an air dryer, filtration system, air receiver, and the oxygen, the PSA towers, and oxygen storage vessel. So each component plays a crucial role in the overall functioning of the plant. And in the next slides, I'll briefly explain their functions. So starting with the compressor is responsible for providing a continuous supply of compressed air into the system. So it has intake filters that ensure that the air is clean before entering the compressor. So there are actually different types of compressors used in PSA plants, but the most common is the oil lubricated rotary screw compressor. So on your right is a typical compressor of a PSA plant. They're actually large and their pressures typically reach 4.5 to 7 bars. So on the next slide is an image that shows how a rotary screw compressor works. So it uses two interlocking helical screws attached to rotors, and these rotors rotate in an opposite direction, such that the screws interlock each other to create a sealed compression chamber when rotating. So as the rotors turn, it creates a vacuum at the inlet, and the air is drawn into the gaps between the screws. So actually this trapped air compresses as it travels down the screws, and the air is forced through the output. So as the air is being compressed, the oil is injected into the compression chamber. So this oil acts as a coolant and a hydraulic seal between the screws, and this makes the compressor achieve high pressures. Yeah, so the next component is an oil separator. So as I said, during the compression process, oil is injected into the compression chamber. So this results in an air-oil mix at the output of the compressor. So the oil separator is the component that separates the oil from the compressed air. So the next component is an air dryer. So an air dryer is responsible for removing moisture from the compressed air stream before it enters the adsorption beds, which contain the zeolite material that can easily be damaged by moisture. So there are actually different types of air dryers used in PSA systems. So the first one is the refrigerated air dryer, and the second is a discant air dryer. So the one on the left is a refrigerated air dryer. So it works on the principle of condensation. So as the compressed air is passed through a heat exchanger, that is the refrigerant coils, it is cooled to a temperature where the water vapor in the compressed air condenses into liquid water. So that's typically about 3 to 5 degrees Celsius. So that's a dew point of water. So this condensed liquid water droplets are collected at the condensate drain of the air dryer. So while a discant air dryer uses a solid discant material such as silica gel to absorb moisture from the compressed air. So they consist of two vessels filled with the discant materials. So when in operation, one vessel is actively drying the airstream passing through it, while the other is being purged with a small portion of the dry air, hence regenerating the discant material. So this operation is done in a cyclic manner, alternating between drying and regeneration cycles of the discants. Yeah, so the next component is the filtration system. So in a PSA plant, there are various filters that are used to remove solid particles from the air, such as dust and trace amounts of oil in the compressed air. So after the oil separator, the air will go through these filters. So a series of coalescing filters are used to remove the oil particles of varying sizes, typically from 5 microns to 0.01 microns. And another filter is called the acrylic charcoal filter, also known as acrylic carbon, which further removes moisture and other harmful compounds. So these filters can be filtered with to an automatic drain system that ensures that the filters are always drained and any accumulated of foreign particles in the filters are drained. Yeah, so the next component is an air storage tank. So this simply acts as a storage for the compressed air. So this helps maintain a consistent air supply that dampens any fluctuations in the compressor output. Yeah, so the next component are the PSA towers. So these are actually the heart of the system of the PSA plant. This is where the separation of oxygen from the compressed air takes place. So they contain the porous absorbent material, the zeolite, which essentially absorbs the nitrogen while allowing the oxygen to pass through. Yeah, so most of the control valves, as you see in the next slides, are contained within this within the PSA power tower system. Yeah, so another component is the programmable logic controller. Yeah, so it is the brain of the PSA plant that controls and automates the oxygen generation process. So it connects between the switching of the absorption and desorption cycles. Yeah, and finally on my list is a oxygen storage tank. So this tank stores the product oxygen that has been produced by the plant, and it also acts as a buffer for the downstream applications, for example, cylinder feeding or feeding to the hospital. Yeah, so actually, on the next slide, a continuation of components that I will not explain in detail, but they're still part of the PSA plant. So on this list, some components may be found in other PSA plants, while others not. For example, a booster pump, which is crucial for plants that have an additional feature of refilling cylinders. Yeah, so yeah, thank you for listening. I will now hand over to our host, Elizabeth Ntabalaba. Thank you.
Thank you, Irene and Lloyd. So at this point in time, let me invite one of our guests, Grace Banali, a biomedical engineer for Partners in Health Malawi, to take the floor. Over to you, Grace.
Thank you, Elizabeth. Hello, everyone. My name is Grace. So I'm going to take you through operation and safety of oxygen plants. So normally, to ensure that every part of the machine is going to work properly and we are going to do our operation without any hurdles, we have to make sure that we do the pre-start inspection as the first step, followed by the startup process. And after that, that's when the whole operation starts, and then we finish by the shutdown process or shutdown procedure. So on the pre-start inspection, We do this normally to ensure that every part of the machine is in a good operating order. So we check the valves, we check the pressure gauge. We also have to check if there are any leakages before we start running the plant. So as we know that valves like the relief valve are there to prevent excess pressure from building up. So if we have a malfunction or a relief valve that is not working, it means we cannot know the time when there is a malfunction in the machine. So we have to make sure that the valve is working. We also need to make sure that the drain valve are working, because these valves are there to remove excess moisture before the filtration process begins. So we have to make sure that everything is in good place. So we also need to observe if there is any abnormal feature in the oxygen plant container before we start running the plant. So we do this every day before starting to run the plant. First of all, we have to do the pre-start inspection. It's something that you cannot run away from. And after checking that everything is in order, that's when we start up the process. So starting up the process, we have to do everything gradually, because we know that oxygen is not like any other air. It's flammable and it can cause sparks and all that. So we have to make sure that we do everything gradually. We turn off the power supply, and then after some, and if, for example, if the oxygen plant has the GPRS encompassed in it, we have to turn on the GPRS battery to allow for a monitoring, distance monitoring, if at all we do that with the plant. So we turn on the GPRS battery, also switch on if we have the CPU, the UPS, I mean, you also turn it on. Yeah, so after that, that's when we turn on the compressor power supply, and then we check on the if at all we have the touch panel. That's where we turn on the compressor power supply. So after that, that's when the compressor starts running. So when this is happening, we have to make sure that we are paying close attention to values like temperature, pressure, flow rates. So if we observe any abnormal value, there are ways that we use to modify the parameters to attain gas purity. So after the compressor is turned on, that's when you go ahead to continue the process. When you start operating, that's when you turn on the PSA plant concentrator. That's the part where we have those absorption towers. So we let some time the purity levels. If we see that the produced oxygen is having low levels, not the recommended level, which is supposed to be 93 minus or plus 3. We dump the air to make sure that we keep on dumping the air to make sure that we have the average values. Yeah, so cylinders, there are some important measures that you have to check. Normally, when you're working with cylinders, you have to make sure that these cylinders that you're using are good cylinders. They don't have any cracks that can lead to you don't have so we should also make sure that the cylinders have the valves in place and they are well fitted, and also they have the valve guards. This prevents them from being destroyed in any cases that either if they can fall down. We also do this to keep ourselves safe from any accident that can happen if at all those valves can get open. Make sure that these cylinders are fully secured to their lock. So we make sure that
Grace, can you
when
repeat the question?
hello,
Yes, hello?
Now you're
yeah,
audible.
can you hear me?
Yeah,
Okay,
you can
thank
go
you.
ahead, please.
Yeah, so okay, thank you. So I was touching on the shutdown procedure, that you make sure that all the valves of the cylinders are closed, and you also make sure that you have manually switched off the booster pump. You also make sure that you have closed all the valves that are leading to the tanks, and also you have switched on the PSA, the concentrator part, and you also end up switching the compressor itself. That's when you can turn off the whole machine. That's the actual procedure that you're supposed to follow. So finally, I'm going to take you through the safety guidelines, which are also vital for operating the oxygen plant. So as you know that oxygen plants play a vital role in generating and providing life-sustaining oxygen. Normally for us, we use it for medical application. So, however, if we are operating these facilities without strictly adhering to the safety protocols, this can lead to accident and can be hazardous to us. So we need, and we emphasize that we need to make sure that we adhere to the safety measures. So whether you're a medical professional or you're a technician or you're an engineer, you need to understand these guidelines, because these guidelines can be variable if you ever find yourself operating an oxygen plant. So the first guideline that I'm going to touch base on is the personal training and awareness. So next slide, please. Yeah. So on this guideline, so as you know, maybe some of you might have heard, before you even start operating the plant, you go through training. Normally, these trainings are offered by the installers or the manufacturers of the oxygen plant. So, you know, when I started out, I didn't fully grasp the importance of training until I faced a sudden equipment malfunction. So I know that it was my thorough training that kicked me in, getting me through the emergency procedure and preventing a potential disaster. That's why I can't stress enough the significance of regular safety briefings and training sessions. They are not just routines. These trainings they are lifelines in critical moments. So you need to pay attention. If either you get yourself into a training like this, you need to pay attention, because these trainings help us every day and every now and then as we are learning the plant. The other safety guideline is equipment inspection and maintenance. So, you know, in my time of operating the plant, I have learned the first-hand importance of keeping an equipment into top shape. So there was a time when we got a tiny valve leak during the routine checks. It seemed insignificant at first, but it couldn't turn into a major safety hazard. It could have actually turned into a major safety hazard if it was unchecked. So I can say that that experience really drove me the importance of maintenance and inspection. So from compressors to valves, every component, you know, it plays a crucial role in keeping our operation running smoothly and safely. So we need to ensure anytime we are running the plant, if you are actually running the plant, you are currently running the plant now, or you run a plant in future, that's a very good guideline that you have to ensure that they are regular inspection and maintenance. The next, I think the next presenter is going to touch base more on that. So I'm going to leave it, or I'm going to leave it at this stage. I'll take the third safety measure. That's the safe oxygen storage and handling. So as I already touched base on that, I talked about the cylinders, how they're supposed to be. So this is just there to prevent any fire hazards. So if we have crags, or if we have damage, we don't have these cylinders handled well or secured well to chains or something like that. And if we have like heat or sparks around close to the storage tanks, this is very very hazardous. We have to make sure that our cylinders are secured at the right place. So you need additionally, there are approved containers that are there that can be used for cylinder storage. So I mean for oxygen storage. So we need to make sure that we are using the right containers for keeping this oxygen. And the other point that I'm going to touch base on is the fire prevention and control. So normally in our oxygen plants that we learn, we are provided with the fire safety control, most especially the fire extinguishers. So these are there to help us in moments that if in case we get close to the moment where there are issues to do with fire. So there are also sprinkler system. So these are light tools. So these tools can help in times where there is fire. We can be able to control the fire. So we have to make sure as operators, if we are going to operate a plant in future, we have to make sure that oxygen plant has the fire control systems. The other guideline that I'm going to touch base on is the emergency preparedness. So every time when we don't have any emergency preparedness with us, we should know that we are going to face big damage. So I picture the last time we conducted an emergency drill, it wasn't just another exercise, it was a rehearsal for real life scenario. So being prepared isn't just about having a plan, it's about practicing it until it becomes second nature. So whether a simulated leak or the equipment failure, all our preparedness ensures a swift coordinated response when it matters most. So we have to make sure that we have the evacuating routes, assembly points, and in case that we have leakages, we should have on hand like the first measure that we are going to do to make sure that we resolve the leakages before they can lead into something that is dangerous. The other guideline that I'm going to touch on is the personal protective equipment. So as engineers or technicians, we know that personal protective equipment are like a gear that we use. Like we have to make sure that we are safe from the surroundings. So I will share you my personal experience. So once wearing a proper PPE shielded me from a potential harm during a chemical spill. So, you know, from goggles to gloves or protecting clothes, like most of us, we wear wetsuits. Those are the recommended safety gears that you're supposed to put on. And also, you're supposed to make sure that you are wearing safety boots, because in case that we have let's say you are trying to take a cylinder out of its lack, and then you did not wear or you did not put on your safety boots, for example, and then you have spilled on something or something has happened, maybe you have lost conscious, whatever, you might end up falling down, and that cylinder might be, before you know it, might be on top of you or on top of your fingers. So you need to make sure that you are safe, and that's what we follow every time we are entering the plant. That's the safety protocol. We are supposed to wear these gears, so we always follow that. The other guideline that I'm going to touch on is the hazard communication. So normally in oxygen plants that we operate, they have labels, safety data sheets. So these are provided mostly by the manufacturer. So this help us to know the procedures to follow. So they serve as a constant reminder of potential dangers. So it's a very small details that keep us vigilant and aware of the surroundings. So it ensures we work safely and responsibly. So I like this concept of having the labels on the light away in the plant, because sometimes I know technical people might feel like we can take a shortcut for this. So when we have those labels with us, I think it gives us, it puts us as a reminder that we don't need to take shortcuts, or we don't need to leave other protocols because we just want to get things done. We have to follow every guideline that is there. And the final guideline that I'm going to touch base on is the regulatory compliance. So mostly all the plants that we operate, they go under inspection. So there are bodies out there that do that. So there are standards governing oxygen plant operations that are there. This includes a set of procedure that, or I should say, instructions that are set by regulatory agencies such as the Operation Safety and Health Administration, OSHA, or the NFPA, the National Fire Protection Association. So these ones help give these manufacturers the regulations that they are supposed to follow. So when we are so it's for me, I feel like it's not about upholding or commitment to the. It's not just only about upholding or commitment to safety and its excellence. So it's also ensuring that we are operating as operators. We are operating in a highest standard oxygen plant. So it's also a good check for us as operators to make sure that the plants that we are operating on are adhering to the regulatory compliance, or in a case that we see that this we see something that we can conclude that is not complying to the regulatory guidelines. It's better it's good we communicate that or report that to our supervisors or anyone else who can help us to make sure that we are safe as we can be. So for me, these experiences aren't just lessons for me, they are insights I've gained over the time that I've been working in oxygen plants, and I hope they serve as variable guidance, guide us for you, whether you're operating a plant now or in future. So stay safe, stay vigilant, and remember we are all in this together. I'll pass on to the host to continue with the presentation.
Thank you so much, Grace. That was really wonderful. So let me take this opportunity to call our next and final guest, Francis Sambani from Partners in Health from Lesotho. So over to you, Francis.
Thank you, Elizabeth, and hello everyone else. My name is Francis. So I'll take you through the maintenance of PSA plants. So firstly, we'll start by looking at plant preventive maintenance, which is just a form of scheduled maintenance of how, next slide please. Yeah, which is just a form of scheduled maintenance of how, whereby you have a schedule, okay, this is when this thing will need to be placed or something like that, or form of like a daily checklist. So typically on a PSA equipment, you have yourself doing house cleaning as part of the PPM. So house cleaning, basically, as the name is, you just make sure that your internal, where your PSA is, either containerized or inside a room, you make sure that it's clean inside and it's free of dust or debris. Make sure that every time. Okay, never mind. So the other thing is also your outside also has to be clean as well around the PSA plant. The other thing that you look at is also the air compressor maintenance checklist. We'll go through that shortly. And also you have the oxygen filling compressor maintenance checklist, which is similar in the sort of sense to the air compressor maintenance checklist. But of course, the tasks that you do on the air and the oxygen compressor will be different. And then you also have a PSA plant performance daily checklist. So the daily performance checklist is also something that you also don't have to skip every time you're running your plant. Make sure that you're also taking note of that. The cylinder filling control record form just helps you to make sure that you track your cylinders, you know at what which batch was filled, at what purity that batch was filled, and just in case there's some issues, so that you can go back and make sure that there's a quality control around your cylinders. So I'll just try to share on what an air compressor maintenance checklist looks like. So an air compressor maintenance checklist would look something like this. So this is for a specific compressor. This is an Atlas Corp compressor used at a certain PSA plants or certain PSA plants here in Lesotho. So this one requires you that daily you check the oil level of your compressor. Is it on the optimum level? If it's in the minimum level, you try to top up if needed. And also you check the readings on the display, check the temperature. Is it within the optimum operation range? Or check the pressure dew point. Is it good? Typically, it would be around 3 degrees Celsius, but for our plant, we run it at less than 5 degrees Celsius. So there are a lot of things, like when do you change your oil and the oil filter, and also the oil separator cartridge. For this one, it will let you change those at 8,000 hours. So there's a lot of things that tasks that I won't go through because of time, but yeah, this is typically what an air compressor maintenance checklist would look like. And then the other would be the PSA daily maintenance plant performance checklist. So this one is just whereby you take the operator's name, write it down, the one who was doing the task that day, the date, and then you check the AC temperature. Some PSA won't have an AC inside. The AC just helps to make sure that the inside temperature is controlled, because let's say, for example, over here, sometimes over the winter it gets really, really cold, so you have to make sure that you're maintaining the temperature inside the room. And also sometimes over summer it gets really hot, so you also have to make sure that you're lowering down your temperature of the AC to make sure that you're maintaining that optimum operating range for your equipment inside the PSA plant. You also record the pressure dew point, CO2 and CO level. You get the ambient oxygen level. You have to make sure that the ambient oxygen is within 21 degrees Celsius, not more than that, because if it goes above 23 degrees Celsius, it poses a hazard, a risk. So yeah, you check the running hours for both your booster and air compressor, and you also take note of the booster compressor inlet, as well as the first, second, or third stage pressure gauges. So the oxygen compressor would also have its own checklist. Some oxygen compressors do have do require you to put in oil, like the RIGS 2 V3. So yeah, depending on what your air compressor is, you just follow it, and follow what you have to do, the tasks that you have to do, either on a daily or a 1,000 hour basis, or whatever time it requires you to do. So that's what you look at on the PPM, like your plant preventive maintenance. That's how you take care of your plant. Moving on, we'll look at the corrective maintenance. So on the corrective maintenance, corrective, as the name suggests, this is just you trying to correct an already a problem that has come about. So you're trying to attend to the problem and rectify it, so that you have your plant back to service. So common problems that you experience with your PSA plant would be something like having oil in your air after the air dryer going to the air storage tank. So mainly what can cause this, for you to have oil in the air going to your AST and eventually your PSA generator, would be if maybe you're in the oil separator, in the oil air separator, you have a cartridge, oil separator cartridge. So that helps to separate the oils and the air. So if that is sort of not in a good condition, that can affect the quality of air you're getting to your PSA generator, and then have oil in that air. And also maybe if your oil scavenging pipe, because inside that same oil separator cartridge, you have an oil scavenging pipe which tries to scavenge for the oils, the residue oils that are in the oil separator cartridge. So if that one is blocked, that means you have oils inside your oil separator cartridge. So you might end up having more oil going to your PSA generator. So maybe you check the condition of those two and see if that helps solve the problem. For in our case, for example, we had this problem. We didn't check out those two, but what we did change was the eco-drain, the last eco-drain, not the air dry eco-drain. Eco-drain is just short for electronic condensate drain. So we changed that. That solved our problem. Not only that, we also changed the three coalescing filters that we have. So that got rid of our problem. So you can try either checking that side, or also checking these three. Two. So you might also have no paging on your equipment, on your PSA plant, on your PSA generator. So in case you have no paging, this would normally point out to your valves. Maybe check all the feed and the waste valves, how they are, how they're performing. Are they opening up? Or also maybe check your exhaust muffler. Is it blocked? Or what's the condition of your exhaust muffler? That might help solve the problem of it not paging, of your PSA generator not paging. And then if you have air or oxygen leaks along your pipelines, this is a simple thing that you also have to check on a daily or every time you run your plant. You just check using your degreaser, which in our case we use Simple Green. So you check all the high pressure pipelines and see if you have any air or air leaks, sorry, and then you try to fix those problems, the leak that you have in your system. So, and then if your compressor won't start, that might point out to maybe it might be upstream, or it might be the compressor itself. Upstream, that is where the compressor gets its power from. Might be that maybe someone was working on something and they changed the phases, something like that. Or maybe your motor overload switch tripped, which monitors just the current going to your compressor, and maybe it tripped. So that might be why your compressor won't start. But also, it might also not start just because of maybe over temperature. So that's another problem on its own. So we just go to that one when we get there. And then you might have water in the air going to the PSA generator. So if you have water in your air, that might point out to the air dryer. Is your air dryer effective? Is it performing within the right temperature? So check the temperature of the air dryer, the temperature gauge of the air dryer, if it's within its optimum operation range. Check the condition of the air dryer itself. Is it clean? Because the air dryer needs to be clean. It has a fan blowing on it. If you have dust or dirt coating the pipes along the air dryer, that will reduce the effectiveness of the fan. Is the fan working? That might also be something that you might have to look at, if your fan is working or not on your air dryer. So those are some of the things. Also, the other thing would be to check your eco drains if they are working as well, because the eco drain also remove the condensate as well as oils. But you should make sure that you don't have oil. Like, there should be like minimal trace, like close to zero amounts of oil in your condensate. And you shouldn't get any oil on the second two filters. The last two filters going to the AST. You shouldn't have oils there. If you have oils there, go back to the to why you might have oil in your system and try to get that sorted out. Moving on. So this picture just show like the motor override switch. That's the motor overload switch on the far left, and then in the middle, you have the oil separator cartilage. The oil separator cartilage is close to the guy with the shoes. That's your oil separator cartilage, and then you have the lead that closes on top of the oil separator cartilage. And then, if you can see closely, you have a pipe that is pointing up on that lead thing. So that's your your oil scavenging pipe. And then you have that picture on the right showing the dryer temperature gauge. And if you can see clearly, you have blue and green. So green is the optimum range, and then you have red. You don't have it to have in red. This is an example of what water in your air would look like. So this is a picture that was taken here at Maluti SDA Hospital. So of course the conditions for this plant are quite different. Like why it was like this, because we had the dryer after the AST. So this would be excused, but yeah, this is just to show how extreme it can get, because if you can see on the second picture, you have a lot of water, more than like over 20 liters of water drawn away from this AST vessel. And this is a picture taken right here from Botshabelo. This was during a routine maintenance. So we found out that the belt, if you can see, you have black debris wearing out from the drive belt itself. So this might have just been caused by probably, because when you're replacing the belt, you have an allowable deflection, tension deflection, and that is allowed for this specific compressor. It's 1/2 to 3/4 inch deflection, which is allowed, and the tension force should be 10 pounds. So yeah, might have just been misalignment, something like that. Maybe it wasn't forward, or over time, because of running, a problem existed and we overlooked it. Yeah, so yeah, that's just an example of what would happen also in your PSA plant. Next up. So in terms of how you can take good care of your spare parts, having spare parts on site is very crucial, because if you have spare parts on site, in case you have a breakdown, that would reduce the time for you to have your plant back to service. And also, you should make sure that you restock your spares as soon as they're running out. So this picture just shows an example, a bad example of a good example of a bad spare parts management. So you don't have your spare parts inventory looking like this. So make sure that your spares are well organized, well stocked, well labeled. You know, if someone new comes at your PSA, maybe for service, they know where to find what. Yeah, so that you have your plant back to service. So you also need to know what spares you need for your you need to know what spares you need for your PSA equipment, the booster compressors, the PSA generator, or the air compressor. Yeah, so you need to know what spares you need, for what period of time are you planning to have these services for, and then you plan out that, okay, we need to stock this amount of equipment, and yeah, you try to work towards that. If you see that your equipment is running out, before it runs out, you make sure that you order more spares. Next slide, please. So this is a good example of spare parts management, making sure that you're in control of your spares. So this is from a hospital that I've said before, Maluti SDA Hospital. So this was a donations, and also, so it was hard for them to get parts for this PSA plant. So what happens, like you can see the booster compressor on the far right, it was hard to get spares for that. And also I talked about the arrangement of this plant. It was I don't know how to say it, but yeah, it wasn't what I'm accustomed to. So you had your air, they had the air compressor, and then after the air compressor they had the air storage tank, and then after the air storage tank they had the dryer, and then the filtration, and then the PSA generator, and then the oxygen storage tank, and then the booster compressor, which you can see on the far right. And if you can also see on the bottom middle picture, you have the the vessels. Both of them actually were not boarded down, so that's also a hazard on its own. So we had to arrange this whole system, having the air compressor, and after the air compressor have an after cooler. The after cooler just helps to cool down the temperature of the air. It does help and reduce moisture, but not like 100%. Maybe it's a good percentage, over 50%. And then yeah, after that we had to change the air dryer, which you can see on the middle upper picture, the red thing. That's the air dryer. We had to change it to put it before the tank, which you can slightly see on your left in the same picture, middle picture. So we had to change it so that we have the air dryer and then the filtration after the air dryer, and then that goes to the air storage tank, so that you have clean air in the air storage tank. So the after the storage tank goes to the PSA generator, then the OST, and then we also had to replace the compressor itself, put in a compressor which we can easily source for parts. Yeah, and also have less time stressing about where to get parts and how long the parts will come. So it is good to manage your spare parts properly, so that you don't have this type of things happening, because this plant went down for close to 2 years just because of spare parts. And then on you maintaining your tools, is a very good thing for your PSA plant. So first, we recommend having a set of tools reserved exclusively for your PSA plant, and not those to be used elsewhere. But if you have to, which we don't recommend, make sure that you have them cleaned each and every time. Even though they are exclusively for the plant, you also have to clean them each and every time. Yeah, so make sure that your tools are clean and kept free of oil or grease. On the picture on the right, on the pictures on the right, we just have an example of what a clean tool would look like, and an example of what a grease tool would look like. So make sure that you have your tool looking as clean as the top picture. And also, what you will notice is that you have your equipment inside your PSA plant. Some equipment might run on might be from the Imperial. Yeah, they might require an Imperial tool set. So make sure if your air compressor or booster compressor requires an Imperial tool set, you have that, because they have a small difference. And the problem with if you use the wrong tool, you end up damaging the edges of your nuts, and eventually those nuts you won't be able to use the tool that you were supposed to use on that nut. You have a challenge opening that. We've had this problem before here at Tabelo, where the screw for replacing oil in the air compressor went to that point that we had to replace because of using the wrong tool on that specific nut. So make sure that you use the right tools, and also have a tools inventory to make sure that your tools are well managed, so that in case of a service, you know that all tools are available. You have your torque wrench, you have everything else that you need for your service. Yeah, so that you know that if anything got out, you know where it is and how to get it back quick. Next slide, please. So just some good practices which you might use to make sure that your plant lives long enough is, as Grace already pointed out, you always operate your plant appropriately. This will be different on different plants as well, depending on who the manufacturer and what the manufacturer recommends. So you run it according to those specific guidelines. So you also don't ignore small problems. If maybe you're getting a high pressure dew point error or something else, you try to take a look at that. Why is it that you're getting that, and try to go through that problem and try to fix it. You should always make sure that your plant is clean and free of debris. That helps your instruments inside so that they run properly. And as we said, like you have the oil or air cooler, also you have the air dryer, which might over time accumulate dust. That's why you have to keep them clean. So if your plant is clean, it will take a longer time for those areas to accumulate dust, and yeah, that will help improve the performance of your plant. Also, you should make sure that you perform your maintenance on time and also appropriately. If you have to change oil in 3,000 hours, let it be 3,000 hours. Don't extend it to 4,000 hours. And also when you're doing the procedure of changing oil, make sure that you do it properly. It's always a good practice to plan ahead to make sure that if need be for something, you have it already in stock. That's why we said try to look at your spares. If you see them running low, try to make sure that you reorder the spares that you need for the next period of time that you be performing your services on your plant. So on the right, we have pictures of what tools to use and what not to use. The shifting spanner isn't really recommended, but it's a better option than those tools below, than the pipe wrench and and the other tool. So make sure that you use the right tools and not tools which would end up eventually damaging your nuts and making you have problems for you to do a certain service on your PSA plant. Coming this far, I'd like to thank you all, and back to you, Elizabeth.
Thank you so much, Francis, and thank you, everyone. Now the floor is open to questions and comments. So feel free to raise your hand or type your question in the chat, and I'll make sure that I should acknowledge you and grant you an opportunity to ask. Any questions? Okay, our first hand, I can see Gulag. Please, Gulag, go ahead. Next, be followed by Masanja.
Okay, thank you very much for the presentation. I have to say I really appreciate, because I've been trained on PSA plan before this time, and this course is like a refresher course. Although I didn't start on time, but I would like to. I have like 2-3 questions to ask. Can you hear me? Can you hear me?
Yes, we can hear you. Please go ahead.
Okay, one. How is the PSA plant arranged? Like the parts from this part, second part, how is it arranged? I want to get that. Then secondly, if the PSA plant's purity has gone low, what do you do? If the PSA plant purity has gone down, what do you do? Then thirdly, if you want to put on the PSA plants, what are the components that you need to press or something? Then if you want to put it off, how do you go about it? Those are the 3 questions for now I would like to ask.
All right, thank you, Gulag. I'll now let our engineers to answer these questions, one of which you say, how is the PSA plant arranged? And if the purity goes down, what do you do? When you register low purity, what do you do? And now the last one, you're saying, if you want to order, make the PSA plant work in me, consult or get them. So please, our engineers, feel free to answer the questions.
All right, I'll take those questions. Can the presenter please just go to one of the first slides where we had the arrangement? Like, I think we had an arrangement of of how it looks like. Yeah, so typically, this is what it would look like. This is how the arrangement would look like. So, you have the compressor, which compresses your air, and then you have a filter there, and then you have an air dryer. So this is, the arrangements are different, honestly, but this is one how it would look like. So the compressor itself would also have an aftercooler inside, and then you have your air dryer, and then your filtration, and then your compressed air. This is how our plant is also arranged. So typically, I think this is a better arrangement, because I think it's better to have clean compressed air. As in the images that I showed for Maluti, we had the air compressor in just after the compressor, and I don't think that's a good arrangement for me. So because sometimes you might need the compressed air, like just the compressed air, because it's been filtered and all. Yeah, so you might need that. Some arrangements will be like you have this compressed air going to the hospital, being used as medical air. So for me, this is a good arrangement, but maybe there might be other arrangements out there which I'm not aware of. and then you have your oxygen PSA generator, and then your oxygen storage tank, and then your booster compressor after that, and your cylinder filling manifold if you're filling cylinders, or your direct pipeline going to your watts if that's the case also. And then the second question was about purity. What would cause the purity to go down? Just a couple of weeks ago, we had this issue of whereby our oxygen our PSA plant was around 87, 88 percent of oxygen. So what caused our plant specifically was the valves. The valves, they were opening, but I would suggest they were not opening fully. So we literally just had to change the entire set of valves, the equalization valve, the feed valve, the waste valves. We didn't change the exhaust muffler. It was just it was in a cape condition, not the time you had to change it. But in our case, we also had like 2 minor leaks, but after solving the leaks, they didn't help to raise the purity. So in other cases, a leak, an air leak, an oxygen leak would cause the purity to go down. In our case, it was the valves. We can't really say which valves because we ended up just changing all valves, like the equalization valves, as I said. So that solved our problem. Your last question was the shutdown process. I'm sorry, but then this question, I feel like it's specific to a certain plant. I mean, to specific plants as well. But generally, after your, let's say if you have a cylinder filling manifold and your plant is for filling cylinders, what you do when automatically, for example, for our plants, the booster compressor will stop once the set filling pressure is reached. And once that is reached, what you do next is you close all the valves for the cylinders. You close all the valves of the cylinders. Once you close the valves of the cylinders, you open the vent valve on your high pressure filling manifold, because you still have some air left in your pipeline. So you open the vent valve to get rid of that pressure inside. And once you get rid of that pressure, you vent out that pressure. What you next do is you can now remove your cylinders, and once you remove your cylinders off of the manifold, you cover the end of the pipes which fits to your cylinders with a plastic to make sure that you don't have dust accumulating on those areas. So that's how we shut down our this is not like a complete shutdown, but then if you're shutting down, you then go backwards. The startup process would be like you start with an air compressor, then the PSA generator, then the booster compressor. But the shutdown would be like once you've done those that I've said, you now switch off your PSA generator. And after you switched off your PSA generator, I don't know if you're shutting down to fuel again tomorrow, because that's a different process as well. That means if you're shutting down to fuel again tomorrow, you just close your AST, because it will still, your OST, your oxygen storage tank, will still have oxygen in it, like air in it, because you can use that tomorrow as well. But if it's going to be a while, you make sure that you vent the OST as well as your AST. You vent it out as well if you're not going to repeat the same thing tomorrow again. And then you switch on your air compressor, you switch off your air compressor, and you now switch off your entire plant and your AC.
Thank you so much, Francis. I think that was well explained. I'll just check some of the questions from the chat, and then Masanja will go. At first, we're having this question that says, do you have a picture of a well-stocked inventory? I think this one goes to you, Francis, again. And then there is another question from Bernard from Kenya to say, what is the problem when the PSA generator keeps only generating, hence the oxygen generation? So before answering to these questions, Masanja will go, and then we'll have our engineers to respond to the questions. Thank you. Over to you, Masanja.
Yeah, hi Tim, how are you? I have my observation that I would like to air from this presentation. One is about the spares store. I think there were two before and after. That contradiction to me is the photo for the first photo for spare stores that we should not emulate is fine maybe. But the second now, it was not a spares photo. It was just the PSA layout. If you can see them, that we are told this is how the spare. No, that was not the spares. I think during printout, some slide was forgotten somewhere. Another thing was about those dirty things in the PSA. I think, my dear engineers, we are forgetting one thing. That is one of the important KPIs we should observe is the 5S. Because if you make 5S a key KPI that you discuss every day, you do the audit, and it is part of the meeting of the department. Definitely, you will discover the dirty tools, you discover the difficult to reach areas, you discover the dangerous ones. And to this, we won't expect to see those oil solid so and so. And therefore, I'm requesting you, as part of the 5S, to do toolbox audit at least every month, so that you can identify those data ones as we are giving as examples. So those were my few observations. Yeah, I can see we are running very short of time. I will take more, but otherwise the presentation was splendid. Thanks.
Okay.
Asante.
Thank you. Because of the time, as you can see, we're running out of time. So I believe that we can have better answers to our questions if we let our engineers maybe send the answers to our emails. I think that would do us good. But reaching this far, this marks the end of this call. Thanks to our biomedical engineers for the wonderful presentation. It has been an educative session, and for all further questions, you can email us at info@oxygenalliance.org. And thank you for attending this call. So don't worry, please. If you have more questions, you can go ahead and ask. Reaching this far, it's nothing but goodbye.